So we left off in Unit 10 on parallelograms, and what these notes are going to cover is a special parallelogram called a rhombus. So a rhombus is actually a parallelogram with four congruent sides. So the important thing to notice here is since it's a parallelogram, all of those properties that we know are true about parallelograms, we also know are true about a rhombus. So when we talk about a rhombus, we know some of the same things. So we know just like in a parallelogram that opposite sides are going to be congruent. Opposite sides are going to be congruent and parallel. And that was something we already knew. So we already knew opposite sides were congruent to one another. But since this is a rhombus, I'm actually going to put the same markings on each of the sides because we have four congruent sides. This is something that's unique to a rhombus instead of all parallelograms. All right, now we also knew that these were parallel, so we put these little lines here or markings here to tell us that we know these are parallel. All right, now also just like in a parallelogram, we know opposite angles are congruent. Okay. So what that tells me is that this angle here has to be equal to this angle, and that this angle has to be congruent to this angle. All right. And then the other thing that was also true in all of our parallelograms is that consecutive angles are supplementary. Okay. And so that means if this is 100, that this angle down here would have to be 80, right? Supplementary means adding up to 180. And the other idea that was true for all parallelograms is that the diagonals bisect each other. So that tells me that this length here has to equal this length, and then this length here has to equal this length. Now, notice I did 2 tick marks on this one and 3 tick marks on this one because the diagonals are not congruent to one another. They just bisect each other, which means they cut each other in half. All right? Now, the unique things to a rhombus. So we already talked about 4 congruent sides. The next thing that only applies to a rhombus, all right, so far, is that the diagonals are perpendicular. So we did talk about this a little bit, but perpendicular means we've got our 4 90-degree angles in the middle, okay? And we also know that the diagonals bisect opposite angles. So let's say this rhombus that I'm looking at here actually has those 80 and 100 angles. That would mean in a rhombus, and again, remember, this is only talking about a rhombus, I would be able to say that this has to be 40 and 40, and that these would have to be 50 and 50. And then likewise, I could go all the way around, 40, 40, 50, 50. So let's go ahead and look at a couple of the example problems. All right. There you go. So in this rhombus, the measure of RST, so that's this big angle here, is 67. Find the measure of RSW. So RSW is this. Okay, so remember what we talked about up here is that when it's a rhombus, we know that the diagonals bisect the angles, so 40, 40. So in this case, if I wanted to know what the measure of this angle is here, we just have to take the 67 and divide by 2. So if we divide a 67 by 2, we get a 33.5. Okay. All right, so let's go ahead, and one of the other things, and this is something you don't have to do in this problem, but I just want to talk about it, is if I have a 33 33.5 here. That means this is a 33.5. So if I had asked you to come up with these missing angles over here and here, we actually could do it because I know this is a 90-degree angle. So all I would have to do is add up the 90 and the 33.5 and subtract that from 180. So let's go ahead and take a second to do that, since we've got the time. All right, so if I take the 90 plus 33.5, and I said 180 minus that, then I would get a 56.5 for these angles here. 56.5, which means this would be a 56.5, and I actually could go all the way around this shape if I wanted to. Those are 5s, they just look funny. All right, 56.5, 56.5. All right, so now if I wanted to find here the measure of SVT, all right, SVT is here, and that's what they want us to find. If STV, so now they're telling me STV is 135. So if this whole angle is 135, well, remember what we know about all parallelograms. If this whole angle is 135, I could do a 180 minus 135. And if I do that, I'm going to get a 45. All right. That tells me that this whole angle here, and let's go ahead, I'll do that in this color. This whole angle is 45. So if they want me to just get the orange part of it, well, all I have to do is just do 45. So this angle here is going to be a 45 divided by 2, which is a 22.5. All right. So now let's look and see what we get in this one. So in this one, it tells me that SWT, well, so this is this angle here. And remember, since this is a rhombus, we know the diagonals are perpendicular, which means 90 degrees. So I get to just say 2x plus 8 equals 90. So 2x equals an 82, so x equals a 41. And then last but not least, we have this example where we're being asked to find the value of x if WRV. So WRV is this little angle here, and they tell us this is a 5x plus 5. And then they tell us that WRS. So WRS is here, and that's 7x minus 19. So again, remember, in a rhombus, I know that these angles are congruent to each other, so I get to just solve when a 7x minus 19 equals a 5x plus 5. So I would get 2x equals a 24, so x is 12. All right, so these are our properties of a rhombus. We're going to do some practice on these together, and then we will start rectangles next.